Hey guys, welcome back. I wanted to do another video with you tonight. Okay, I have a slab here. I'm going to go to my custom machining wizard. Existing file, because I'm bringing in a DXF file. Next. Alright, there's my parts. These aren't real parts, guys. They're just things that I've drawn up to hopefully explain things to you, how the software works. Next. Okay, I'm not going to worry about everything else right now. All I want to talk about is how to drill a faucet hole. Okay. We're going to come back and talk about optimizations on the outside and all that, but right now I just want to talk about the faucet holes. Next. Next. Finish. Okay. There are arcs of size too small to be machined with the disc. Yes, it thinks I'm trying to cut those faucet holes with the disc, which I obviously can't do. Alright. A tool. When you're going to drill faucet holes, you have to create a mill. Even though we're using the core drill, you have to, in the software, treat it as a mill. And the faucet hole, I believe, is 1.25 inches. That's a 5/8 radius, 0.625. The tool that you make has to be a few thousand smaller than that hole. If you make it the same size, it will not work. It's got to be a little bit smaller. Okay. So, having said that, let's continue because I just want to do these faucet holes. Alright. So, there's the first faucet hole. I'm just going to edit machining. Alright. 4, 5, 6, 11, 12, and 13. Okay. Now again, as you know, you could rename them if you want. F-A-U-C-E-T, faucet 1, faucet 2, faucet 3, and all that, okay? Also, so I got faucet 1. Depth is going to be 1.1. Alright. I don't want to go all the way through. I want to leave a little bit because don't forget the slab's laying flat on the table. The slug would have nowhere to go. It would go up inside the core drill, and if you go to drill another hole with the slug up inside there, you're going to break the core drill. Okay, so I have a depth, and I'm going to change it to this tool and advanced data. Alright, I'm going to put this at 7 times, subdivide. Next one, main data, there it is, 1.1, okay, advanced data, 7 times, subdivide, and that's also going to be with that tool, alright, that tool, 7 times, subdivide. Take this one. It's going to be with that tool. 1.1. Advanced data. 7 times subdivide. That tool. 7 times subdivide. That tool. Depth. 7 times subdivide. Okay, I knew I missed that one. Just checking to see if you're watching me. Okay. Alright, so that's basically all we need to do. Again, faucet 1, I picked the tool, which again is a few thousand smaller than the hole. Set the depth, advanced data, 7 times, subdivide. Okay. Machining. Now I don't want to do all the other cutting, so I'm going to go to sort machinings, right? Because I want to make sure those go first. Okay, there's the first faucet hole. I want that to be number 1. So I drag it up. Alright. Second one will be 2. That'll be 3. This one will be 4, 5, 6. Okay? Okay, build, ISO, compile. View, isometric, play. And there we go. Drill, drill. Very good. Okay. There we go. Z negative 1.1. Okay. Z negative 1.1. The G1 means it's a straight line, and there's the feed rate associated with it. The M3 turns the spindle on at 1200 RPMs. Okay. Alright, so this program looks good. So that's how you drill a faucet hole. But what I want to do for a second, I just want to go to the tool manager and speak about that tool. Alright, so we're drilling with a core drill, but it has to be defined as a mill in the software, okay? So it's by tool 6, machine code is 1, that's my description, it's counterclockwise. Okay, length 2 is the length of the diamond, radius 2 is the radius. Remember I told you it's got to be a few thousand smaller. Alright, so now you take your calibration value, you subtract the diamond, that equals length 1. Length 1 plus the diamond equals length. Okay? Set your feeds and speeds. Alright, that is how we drill a faucet hole. I hope you enjoyed this video.